Hello, my name is Arvind Venkatesan and I want to present the final project on big data case study in natural language processing. Big data is a collection of huge data sets which is difficult to capture, store and analyze. Example would be Facebook pictures, Amazon products, etc., where we're talking about millions and millions of data points. Natural language processing is an interaction between computer and human language, not restricted to voice as many people think. It also involves textual text-based languages. A brief history. In 1950s, it started the Turing test, where the objective was to distinguish between human and the computer. So the human and the computer were behind the screen, and people on the other side had to find out whether it was a computer or a human that was giving responses. Of course, in later decades, it followed with more advanced kind of programs. Up until recently, we are using more machine learning approaches, where we are trying to learn from data points or data sets to make the computer smarter. Some of the major tasks in NLP are natural language processing, information retrieval, extraction and speech processing. Information retrieval is more to do with storing, searching and retrieving information, whereas in extraction we are more concerned with the meaning of the documents. In speech processing, we cover different areas of speech, for example, speech recognition, text-to-speech, speech-to-text, etc. Big data is helpful in NLP because it's real-world data, continuously feeding the NLP engine and making and evolving it with time. Some of the popular tools are Natural Language Toolkit and Apache Hadoop. Apache Hadoop scales better in terms of data, which is what we're using today. We'll be using Apache Mahout to classify the documents. So coming back to the problem definition, we will be doing document classification, where we'll try to categorize documents across different categories like sports, music, politics, etc. Some of the approaches that come off the hat are manually. We can classify the documents, which may take a lot of time. We can have some hard-coded rules, but then it doesn't scale. And also, if new documents are shown to the classifier, I am not sure if we'll be able to have a reasonable accuracy in prediction. Therefore, we resort to automatic classification, where we'll build a system which has prior knowledge of different documents, and then we'll hope that if when new data comes, the system will be able to predict accurately what category the document belongs to. The two kinds of classification, broadly speaking, one is supervised classification, in which we build the model based on prior knowledge of categories on existing documents. Some techniques are naive Bayes classifier, stochastic gradient descent, etc. In unsupervised classification, we don't know a priori what classification the documents belong to, and we let the system figure it out for us. So there's no external inputs or labeling that goes on before. In the demo, we're going to use supervised learning algorithm, specifically stochastic gradient descent, or SGD. We will run this algorithm over 20,000 documents, which is available on the internet. These 20,000 documents are spread across across 20 news scripts. The technology that we're going to use is Apache Mahout, which is relatively simple to do such kind of tasks. Let's see the design rationale behind the approach that we're using. We're using supervised learning algorithm because we already have a data set which is pre-classified. So hopefully this will put us at on a right foot when it comes to solving this problem. So we plan to first build a model based on known data and known responses, and then once we have the model, we will try to predict responses by feeding new data to this model. Stochastic gradient descent was used because it's scalable and efficient. Specifically, it uses a constant amount of memory regardless of input size. This is a big plus for this kind of an algorithm. So in other words, it scales as a function of input size. And of course, it's very easy to implement, and it gives lots of opportunities for tuning so that we can get better accuracy. Apache Mahout is free and it scales. The best part of Apache Mahout is that it comes pre-built with various machine learning algorithms. So programmers can just reuse to build their models. The intuition for SGD is to refine the model iteratively by feeding all the known examples in an iterative manner. From a mathematical perspective, we are trying to minimize an objective function by changing the parameters of the model, and we hope that upon subsequent iterations we converge to a minima. So as an example, you can see if we kind of vectorize our inputs and outputs, let's say our vector is the square feet for a house and output is the price that we want to predict. What we want to do is we want to predict t, where such that h into t is equals p, where h is the inputs and p is the output. In the demo, we use CentOS 6.532-bit machine, which is a virtual machine on Windows 7 Vista, Mahout 0.7 and Apache Hadoop MRV1 were used along with Java 1.7. Some of the additional settings are Mahout was run as in a local mode, so that we didn't use Hadoop. That was one of the problems we ran into. Getting out of memory with Hadoop. Also, we had to set the Java options because Java virtual machine was running out of memory. And also, the 0.7 version of Mahout has a script error, and the Mahout installation was missing this jar file. Some notes on running this demo. This is a screenshot where we see the algorithm running in action. It goes through various examples, the data sets, and tries to converge. If you see the demo, first time when we ran SGD, we got an accuracy of 73%. Here's the confusion matrix, which shows how the model performed when it was given different data sets, unknown data sets, or the test data as it's called. So for example, in this case, the rec.sport baseball, there were 397 documents that was fed, out of which 184 were classified correctly. In case of rec.autos, out of 396, 316 was classified correctly. Now as you see, B equals rec.autos means that there is this is a label for each category, so that each column you can see what category it corresponds to. We did another run of this algorithm, and this time we didn't get the same results. We got, in fact, lesser accuracy. We got 68.72% accuracy. And it turns out that the SGD need not always converge to the same global minimum every time, unless the objective function is convex. So this is a result of Robin-Sigmund's theorem. And it looks like in our case, with the 20 data news groups, 20 news group data, we don't have a convex function. Internally, the Mahout algorithm, they represent the documents as a feature vector, where you can think of, let's say, one document is a one big row and it has like n columns, where each column corresponds to each feature. The feature can be some of the keywords, or some kind of a group of a classification. So for example, in this new group document, it can be a domain name. That could be a feature. It may have a weight. Similarly, words will be weighed differently based on TF-IDF, which is text frequency, inverse document frequency. The text frequency is how many times a given word occurs within a document, and inverse document frequency is how many times a word occurs across documents. So, so the more a word occurs across documents, the less weight it gets, and vice versa. The challenges for this approach was that the Mahout didn't work well on Hadoop mode because the laptop had 4 GB RAM in all, out of which 3 GB was dedicated to the CentOS. Mahout script needed some fixes. The accuracy for SGD was okay. It was not in the order of 90%. It needed more tuning and certain trials. SGD is more sensitive to feature scaling. What it means is, if we have a feature vector such that each feature has a different range of values, we may have to scale the features so that they are in a similar range, so that it may give better accuracy. To conclude, I want to say that SGD is a simpler algorithm. And intuitively it makes sense, and also in terms of performance, it's good because as a function of input, the memory is still the same, it's constant. There's a lot of potential to be fine-tuned, like for example the weighing of words, the relative weighings, or different parameters like lambda and alpha, which is the machine learning parameters. Also, it's very important to have a stable Mahout Hadoop environment for these tasks to finish properly. Of course, for larger data sets, we may want to store the data in the Hadoop cluster instead of running Mahout locally. I believe the Mahout library is improving more. There are many intermediate steps that can be made more transparent to the user. And lastly, the testing of new data with SGD model is not that straightforward. Reason being, I had to create similar data, similar directories in the file system to mimic the 20 categories that was already there, and then put my data in that to somehow get it to work. All that has been documented in the report. Anyway, thank you so much for listening to this presentation. I hope this was helpful. Bye bye.